Welcome back to Math with Ace, continuing our probability practice problem series. We have a bunch of problems that are dealing with independence, conditional probability, mutual exclusivity, and or, so intersections and unions as well, working through these with given probability values. Klaus is trying to choose where he can go on vacation, and his choices are either New Zealand or Alaska, but he can only afford one vacation. The probability that he chooses Alaska is 0.6, and the probability that he chooses, New Zealand is 0.6, and the probability that he chooses Alaska is 0.35. What is the probability that he chooses both? He can't. He can only afford to take one, so that probability is 0. So even though we can run some sort of calculations if we needed to use some formula, we are told that he can only travel to one. What is the probability that he chooses either New Zealand or Alaska? Well, general addition rule of A or B, that's equal to the probability of event A plus the probability of event B minus the probability of A and B. We know that the probability of event A, choosing New Zealand, is 0.6. The probability of choosing Alaska is 0.35, and choosing both is 0. So the probability that he is going to choose one or the other is equal to 0.95. So there's a 95% chance that he's going to go on vacation, 5% chance he doesn't choose either. Moving on to Carlos. Carlos plays college soccer, and he makes a goal 65% of the time that he shoots. He's going to attempt 2 goals in a row in the next game. A is a successful first goal, and that has a 65% probability, and B is a successful second goal, 65% probability. Carlos tends to shoot on streaks, though, and so the probability he makes a second goal, given he made the first goal, is actually 0.9. So we have a few different things. The probability of A is 0.65. The probability of B is 0.65. And the probability of B given A is 0.9. What is the probability that he makes both goals? Well, he has to make the first one. So the general multiplication rule, remember, A and B is found by taking the probability of A times the probability of B given A. So the probability of A times the probability of B given A means he made the first goal at 0.65, and then we multiply that by making the second goal if he made the first goal. So 0.9 times 0.65 gives us 0.585. What is the probability that he makes either the first goal or the second goal? That's an or. So A or B is the probability that he makes the first goal plus the probability that he makes a second goal minus the fact that he would make both. I need to take away that double counting situation. So 0.65 plus 0.65 minus 0.585. Because if we didn't take away that fact that he would make both together, we would be over 100%, which is not a possible probability. This is 0.715. Are they independent? In order to be independent, the probability of A and B needs to be equal to the probability of A times the probability of B. This means that 0.65 times 0.65 needs to multiply to 0.585, but it doesn't, because 0.65 times 0.65 is actually 0.423, and that's not equal to 0.585. So no, they are not independent, because he goes on streaks. He's actually more likely to make the second shot if he makes the first shot. And are the events mutually exclusive? No. If the probability of A and B was 0, great. But the probability is not 0. He can make the first and then the second shot. So no, they are not mutually exclusive. A community swim team has 150 members. 75 of the members are advanced, 47 are intermediate, the remainder are novice. So we have 150 total. 75 are advanced, 47 are intermediate, which means that 28 are novice. Because 150 minus 75 minus 47 gives us 28. The remainder are novice swimmers. So 40 of the advanced swimmers practice 4 times a week. 30 of the intermediate swimmers practice 4 times a week. 10 of the novice swimmers practice 4 times a week. And then suppose we're choosing a member of the team randomly. What is the probability that they're novice? There are 28 novice out of 150 total. We'll call this, let's say, N for novice. What is the probability that the member practices 4 times a week? This is not the novice member, it's just a member in general. Well, there were 40, 30, and 10 in the different groups that were practicing 4 times a week. If you add all those up together, you get 80 out of 150. What is the probability that the member is an advanced swimmer and practices 4 times a week? Not conditional, but and. So there were 40 advanced who practice 4 times a week out of 150. So it's advanced and 4 times a week. I'm not giving it a condition just yet. What is the probability that a member is advanced and intermediate? You can't be both. How could it be both? Well, the probability of being advanced and intermediate is 0, which means they are mutually exclusive. Whenever you have their intersection being 0, these events are mutually exclusive. Are being a novice swimmer and practicing 4 times a week independent? Remember, there's a couple of different ways that you can calculate being novice or being independent or not. The probability of being a novice and practicing 4 times a week has to equal the probability of being a novice times the probability of practicing 4 times a week. We know that there are 10 out of 150 that are novice and practice 4 times a week. We know that there are 28 novice, and we know that there were 80 that practice 4 times a week. So do they multiply out? This winds up being 0.067, and the multiplication on the right is 0.0996, and those are not equal. So no, they are not independent. All right, hopefully this was helpful, and come back for our last video in this series.